Hi folks, so today we're going to talk about the second step of glycogen synthesis, which is controlled by the flux-controlling enzyme glycogen synthase. Glycogen synthase is going to take our UDP glucose we made from UDP glucose pyrophosphorylase here, UGP in the first step. It's going to react it with a strand of glycogen that already exists to make a UDP and a longer glycogen. So glycogen synthase only acts to elongate current strands of glycogen that already exist. Now, like most enzymes that are involved in flux control steps, glycogen synthase is readily used and controlled by the endocrine system. And that means your hormones make a big difference in controlling this. And so glycogen synthase, you can imagine, does not want to be active if there isn't a whole lot of energy or glucose around. And so things like AMP and those kinds of things should help moderate this activity. The most important ones we want to talk about are glucagon. Glucagon is a liver-controlling enzyme that tells your blood sugar to come back up. And so last thing you want for your blood sugar to come back up is all the stuff you're trying to send out from the liver to go into glycogen storage. And so glucagon is going to repress glycogen synthase. You also don't want to be storing it if you are in your muscles, for example. If you are running away from a lion, you want to have it all available. And so epinephrine also controls glycogen synthase. So we have some controls here. Now those things do the opposite thing to the breakdown enzyme phosphorylase. There's another video on that in the channel, and you can watch that if you like. But these are the two flux controls, glycogen synthase and phosphorylase. So we're going to go into the mechanism here. Mechanism for glycogen synthase starts with the UDP glucose, which we got from the last step, the UDP glucose pyrophosphorylase. There is an enzymatic glutamic acid side chain that's deprotonated in the active site, and it's already bound to an existing chain of glycogen. And the only thing that glycogen synthase does is it makes chains longer. It goes from an N-1 to an N-length glycogen. It's going to kick off UDP glucose, the UDP part, as a leaving group, and it's going to stick the glucose onto the chain using an alpha 1,4 linkage, like all glycogen molecules have. So the way this is going to start is, well, we need to kick off this UDP, and so we're going to start doing that using this enzymatic glutamic acid. So that's going to force off, just essentially by an SN2 reaction, the UDP. Easy enough. So now we've linked a glucose into our active site of glycogen synthase. Notice that we have now got an inversion at that center because we've come in from the top and our hydrogen is now forced down. And so now we're more like a beta bond here. The tail and the link are on the same side. So we've inverted that from an alpha. And our UDP now is essentially free to go, but it has one less trick up its sleeve. UDP is going to pull off this hydrogen off of our existing glycogen chain, give that back to oxygen, and act as a base there. The way I've drawn it here doesn't look like it's super close, but those are actually right next to each other in the active site, and so it makes it easy for it to just pull off the hydrogen to make it more nucleophilic. So now once UDP has done that and gotten its phosphate, it just poofs out the door. So now you can see we have an O negative, we have a nucleophilic oxygen. That's going to come in and backside attack again, alpha this time, kick off the enzyme, and it's going to have made a new alpha 1,4 linkage to glycogen to have lengthened it by a single monomer. So we're left here with a 3-length glycogen chain that we can see and a recharged enzymatic active site. And this is going to go through multiple rounds, and it can just lengthen these things as long as it wants. Now, what's going to happen often is we're going to have a debranching enzyme or a branching enzyme to help keep lots of ends available so that it's easy to break this thing down. We'll talk about that in a different video.